Hi there, this is Miss Chelsea, and I'm going to be going over Module 3 written exam with you guys. I'll pull up my screen share here. All right, so what we're looking at here is using divisibility test. So when we do a divisibility test, we're going to be looking at a few rules to follow. So for a number to be divisible by 2, the last digit has to be an even number. To be divisible by 5, the last digit will be a 0 or a 5. A number can also be divisible by 10 if the last digit of that number is 0. For a number to be divisible by 3 or by 9, you would add all of the digits together, and then the sum will tell you if it's divisible by 3 or 9. So if your sum is divisible by 3 or 9, then that original number will also be divisible by 3 or 9. Then, for the number 4, the last 2 digits of the number will be divisible by 4, and for 8, the last 3 digits of the number must be divisible by 8 for the whole number to be divisible by 8 as well. So for the number 7, it's a little confusing, but it says if you will double your last number, then subtract that from the original number without that last number included. So it would be what you used other than that last number that you doubled. So subtract that from that number, and then if that new number that you got is divisible by 7, then that whole original number will be divisible by 7. For 11, what you will do is add one set of alternating numbers and then add the other set of alternating numbers. Then subtract your answers, and if that number is a multiple of 11, then it is divisible by 11. So here is a chart worked out for you, and I know that it is sideways here. I made a very large chart so it was easier to read. So if you see here, I have the numbers listed, the 684, 2064, and so on. And then there's also the numbers here listed, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Those are the numbers we're going to see if these larger numbers are divisible by. So in each row for 2, we're going to check and see if the number up top is divisible by 2. So for an example, the first one, 684, would be divisible by 2 because the last digit of that number is even. And I'm just going to go over this first column with you, the 684, and then you can look at the rest if you would like to. So number 3, to see if it is divisible by 4, what we would do is add the 6, the 8, and the 4, and that would give us 18. And 18 divided by 3 is going to give you a whole number with no decimals, no fractions, so that means that it is divisible by 3. So 4, to find out if a number is divisible by 4, we want to add the last 2 digits. So the 8 plus 4 equals 12, and when you divide 12 by 4, it gives you a whole number again. So therefore, it is divisible by 4. So for the number 5, to see if it is divisible by 5, we're going to look at the very last digit. And we need to remember, if it's a 0 or a 5, then yes, it will be divisible by 5. So for 684, the last digit is not a 0 or a 5, so it will not be divisible by 5. For the number 6, it has to be divisible by the number 2 and the number 3. So if you have yes on 2 and 3 up here, then yes, 6 will be divisible, or 684 will be divisible by 3, or 6. I'm so sorry. It will be divisible by 6. And then for 7, this is the one that's a little bit tricky. So what you do is you double this last number. So we'll double 4, which would equal 8, and then subtract 8 from the from 68, and that would give us 60. 60 is not divisible by 7 because when you divide that, you're going to end up with a decimal instead of a whole number. So no, it will not be divisible by 7. For 8, what we're going to do is add the last 3 digits of the number. So for this number, we'll add all of those digits, and we will get the number 18. And then what you do is divide that by 8. If that number will go into 8 and give you a whole number, then it is divisible. But in this case, 18 divided by 8 will give you a decimal. So no, 8 will not work. It will not be, 684 will not be divisible by 8. The number 9, it will be divisible by 9 because if you add those digits and divide it by 9, you're going to get a whole number. Number 10, if it's the last digit is a 0, then the number will be divisible by 10. If it is not, then it will not be divisible. So 684, the last digit is a 4. It will not go, 10 will not go into that number evenly. And then 11, that one was also tricky, kind of like the number 7. So what we do is we add the alternating numbers. So for this one, we would add 6 plus 4, and then we don't have a number here, so it's just going to be the 8. So 6 plus 4 is 10, plus the 8 would give us 18. What we do there, though, instead of adding it to get a total of 18, we just subtract the 2 answers that we got. So it would be 10 minus 8 gives us 2, and 2 is not divisible by 11. So that's kind of how you work out those divisibility. You just look at your rules, and then with those rules, you can determine if a number is divisible by another number. Next, what we're going to do is use the process of nines, and we will be checking all of the following answers. First, what we will do is add each individual digit within a set of numbers. Once all the sets have been added, then you will divide that answer by 9, and that's going to give you a remainder. Then what you do is all of the remainders on the left side of your equal sign, you add those, and the number you get there, you will divide that one by 9 as well. Then if that remainder that you get does not match the remainder that you got on the right side of the equal sign, then you're going to have to find the correct answer. And to find the correct answer, all you do is add the original numbers to the left side of your equal sign. And then that will give you the correct remainder. So how you would determine that it is the correct remainder is you're also going to add those numbers together as well, divide it by 9, and that remainder will match the other remainder that you got originally. So we're going to look at a few examples here. For 2a, it's going to be 416 plus 7,490 plus 69,844. And then our original problem gives us it's equal to 112,790. So to break it down, how I was showing you or telling you, is you're going to add each individual number here in this first set. So 4 plus 1 plus 6, that will equal 11. Then you divide 11 by 9, and that will give you the remainder of 2. So you do that on all of your problems. What you're going to be looking for is adding these remainders here at the bottom, and then divide that by 9. Then that remainder here must match this remainder. And if it does not, you will go back and add your original problem, the 416 plus 7,490 plus 69,844. If you add those numbers, you will get 77,750. And then you will divide that number as well by 9. And that will give you the matching remainders, your 8 and your 8 here. So 2b is the exact same. We're using the addition. There's just one extra problem in there, or one extra set of numbers. So that one would be worked the exact same. For 2c, you'll see a subtraction sign here. You still work the original problem the exact same way, but when you get down here to the remainders, instead of adding the remainders, you just subtract those remainders. And then that will give you your answer here, which is 6, divided by 9 would give you remainder 6. And again, it does not match your remainder here. That means that is the incorrect answer. Add or subtract your original problem and get your correct answer, and then divide that by 9, and it will give you the correct remainder. Those two there will match this remainder in this one. Next, we're going to look at one with multiplication. Again, you work the top portion of it the exact same, but when it comes down to your remainders, instead of adding or subtracting, we multiply those, and then we complete the problem the exact same way. Number 3 here says the colored rods shown here are 1 centimeter square and of lengths 1 centimeter, 2 centimeters, 3 centimeters, and so on up to 10. To answer part A through D, we're going to look for the greatest common divisor, or GCD, of each number. So here you can see each color. I have them coded 2 centimeters, 3 centimeters, and so on. So part 3A asks us which rods will measure the 9 rod. So what it's asking us is to just find the greatest common divisor. And to find the greatest common divisor, you are going to just put, a great way to explain it is you start with 1, and then you will list every number that you can multiply to get a 9. So for the number 9, you will get 1, 3, and 9. And here you'll see 1 times 9 equals 9, and 3 times 3 equals 9. 3b, which rods will measure the 6th rod? 1, 2, 3, and 6. We have 1 times 6 equals 6, and 2 times 3 equals 6. 3C says to use parts A and B to show the greatest common divisor of 9 and 6. So we're just going to list the divisors like we did in the last problems. 1, 3, 9 for 9, and 6 is going to be 1, 2, 3, and 6. So what we're going to do is we're going to find the greatest common divisor between the two numbers. So the one number that is listed in both 9 and 6 would be 3. So our answer here is 3 because it's the biggest number that is listed more than once. And 3D is asking us to place the 10 rod and the 8 rod end to end to form an 18 train. Show all rods or trains that will measure the 18 train. So what we're doing is we're just listing all of those numbers again that we can multiply to get the number 18. So we have 1, 2, 3, 6, 9, and 18. 3E is the same as we just did before. I just broke it down a little bit more for you. I listed all my numbers. And then I did the 1 times 18. 18 equals 18. 2 times 9 equals 18. And 3 times 6 equals 18. 3F says it's just basically explaining what the colored rods and how they're good to use for students to understand the greatest common divisor. So they're more a visual way to understand the greatest common divisor. You can visually see how many times a number or a rod can go into a larger rod. Number 4 says for parts A through D, we will use prime power form to find the least common multiple, or LCM, of each number. We will create a table with our numbers across the top, and we will factor out any prime divisor of one or more terms. Then we will replace that term with the quotient. We will do this until the last row contains either a 1 or prime number. So our very first one is we're going to find the least common multiple of 48, 25, and 65. So what we do is we create this little table here where we put 48, 25, and 65 at the top. And you just start out here like with a 2. And if 2 will go into 48, you'll list how many times underneath it. If it will not go into a number, you just simply bring that number down again. So for 25 and 65, 2 will not go into that, so we just bring those numbers down. We'll repeat the same process until we get to the very bottom. And like I said, the bottom row will have to be either a 1 or a prime number, and that's when you know that you're finished with the problem. So then what you do is you just list each of the numbers from this side row here, or side column, and this bottom row. So we have 2 times 2 times 2 times 2 times 5 times 3 times 5 times 13. And the way we can shorten that is to do exponents. We have the number 2 written 4 times, so we would write 2 with the power of 4. We have 3 written 1 time, so we put it to the power of 1. We have 5 2 times, so 5 with the power of 2. And we have 13 once, so it would be 13 with the power of 1. And then we will work the next few problems the exact same way. So you'll just list all of the numbers at the top and work through it the exact same way. So for number 5, it says if you have a gear with 48 teeth that's engaged with a gear with 84 teeth, you will need to find the LCM, or the least common multiple, of each gear to determine how many more revolutions the smaller gear will make before it is again in the same position. So the least common multiples of 48 is going to be 2 to the 5th power times 3 to the 1st power. And then the least common multiple of 84 is 2 to the 3rd power times 3 to the 1st power times 7 to the 1st. Next, we will multiply these numbers together. Divide that answer by the number on the smaller gear, and that is how many revolutions the small gear will go again to be in the same position. And what I did here is I broke it down using that same method we used just a moment ago. I put the number 48 here, and then you see I did the 2, and then that would leave 24. I did 2 again, that would leave 12. 2 again would leave 6. 2 again would leave 3. That is a prime number. We cannot go any further. So I did that here with both of those. And then you just write those out. 2 times 2 times 2 times 2 times 3, which is what we got here for 48. And then 2 times 2 times 3 times 7, which is what we got here for 84. And you will just bring down all of your 2's there, your 3 and your 7, multiply that together, and there is your answer of 336. And for the last one, it says to use the numbers listed, we will make a magic square. First, we will add all of the numbers together Then divide our answer by 3 because our square here is a 3 by 3. Next, we will use the guess and check method to fill in the remaining squares with the numbers provided. Notice that the 0 and the 1 are provided for us, so we cannot use those numbers again. Each row and column and diagonally will add up to equal the answer that we got by adding our numbers and dividing it by 3. So when we add the -7 plus -6 plus -5 plus -4 plus -3 plus -2 plus -1 plus 0 plus 1, that gives us a -27. We'll divide -27 by 3, and that gives us -9. So we want this first row, the second row, and the third row to all equal 9 when we add them up, same as the columns here, and diagonally across here and diagonally across here. So after you use the guess and check method, your box should be filled in, and then you can go back and check to make sure. So we have 0 plus -7 plus -2, that's -9. -5 plus -3 plus -1 is -9. -4 plus +1 plus -6 is -9. And then across here, we'll do the same thing. 0 plus -5 plus -4 is -9. -7 plus -3 plus +1 is -9. -2 plus -1 plus -6 equals -9. And then we'll check the diagonals. We have -2 plus -3 plus -4 will give us -9. And then the diagonal across this way, we'll have a 0 plus -3 plus -6 will also give us a -9. And I hope that helped you have a little bit of a better understanding of Module 3. Again, my name is Miss Chelsea, and thank you for watching.